Water structure. In this video, we're going to look at the molecular structure of water and link that to the properties that water has, and then link that to the importance of water in all living things. Water has the molecular formula of H2O, and this leads it to have the following molecule. The arrangement of atoms in this molecule is very significant because it leads to this bent shape in the molecule, and that is caused because of a disparity in the size of the atoms involved. You see, oxygen is a very large atom with a relatively large number of protons, whereas hydrogen is a very small atom with only one proton. What this means is that the positive charge in oxygen here is much bigger than the positive charge in hydrogen here, which means that the electron gets pulled closer to the oxygen nucleus than it does to the hydrogen nucleus. The result of that is an unequal distribution of charge, which makes the oxygen ever so slightly negative and the hydrogens ever so slightly positive. This sign, incidentally, the sort of delta sign, means a little bit. And here you have the sort of the overall shape of the water molecule. You don't need to know this digit, but the actual bond angle of 104.45 degrees is something that does sometimes crop up in questions. So, what is this? What is the significance of this? What does this result in? Well, what it results in is hydrogen bonds. We're aware that opposites attract, and so what you end up with is that you end up with your slightly positive hydrogens being attracted to your slightly positive oxygens, and that causes these hydrogen bonds to form between the molecules. Now, about hydrogen bonds, chemists don't call them bonds, they call them interactions. They're not a physical bond, but they are a force of attraction, if you like. One hydrogen bond is exceedingly weak, many hydrogen bonds altogether extremely strong and requires a lot of energy to break, and consequently the formation of these hydrogen bonds gives water a number of properties that other molecules with roughly the same molecular mass do not have. So, some of the properties of water. For example, water is a liquid at room temperature. If you were to compare water with ammonia, which has an identical relative molecular mass, ammonia is a gas at room temperature, whereas water is a liquid. Obviously, it being a liquid is very crucial for its function in all living things. The reason why it is a liquid at room temperature is because of hydrogen bonding. Another feature of water that's very crucial is that it is a solvent. It is it's a solvent to not quite everything, but to very many things, and that's because of its polar nature. It is able to dissolve charged particles. That obviously makes it an ideal transport medium, and water is at the basis of the majority of transport systems in the living world. It is also an enormously stable environment. If you think of the very hot summer's day when you're roasting outside and you run into the sea and that hasn't changed temperature really at all, that is because water has a very high specific heat capacity, and that high specific heat capacity is as a result of the hydrogen bonds, and those hydrogen bonds mean that it takes an awful lot of energy to separate the water molecules. And last, but by no means least, and actually not the last of the properties of water, is this thing called anomalous expansion, where what happens is that the density of ice is less than the density of water, and so what that means is that ice will float on water, which is obviously crucial in environments like ponds and in the Arctic, because it allows the ice to make an insulating layer at the top of the water, and it then allows the animals to live and plants to live freely underneath the ice. So this summarises the key points of the structure of water and their properties. Can you match the key words to their meaning? So you have dipole, hydrogen bond, 104.45 degrees, and specific heat capacity. So if we start with dipole, dipole is the uneven distribution of charge. Then a hydrogen bond is the interaction between two polar molecules, or several polar molecules, normally two. 104.45 degrees is the bond angle in water, which leaves specific heat capacity to be the amount of energy required to heat 1 kilogram of a substance by 1 degree.